Hey everyone, this is Project Team 6, and for our machine learning project, we'll be tackling income inequality. So to begin with, this is an issue that was already quite prominent before COVID, where the wealth of the 3 richest people in the world was more than that of the poorest half of Americans combined, and unfortunately, the wealth gap has since been further exacerbated by COVID. As a result, we would like to explore the relationship between COVID and income inequality and see if there are any other factors that would affect a country's income inequality. So in order to quantify this, we'll turn to the Gini coefficient, which measures the difference between a country's current income distribution to one with perfect income equality. A value of 0 is perfect equality, and 1 is perfect inequality, and these measures can be visualized using the Lorenz curve as shown.
In this project, we aim to investigate the relationships between independent variables related to a country's well-being, such as crime rate, mortality rate, and happiness index, as well as COVID-19 statistics. Using this information, we also hope to find significant predictors of income inequality and build machine learning models to predict a country's Gini coefficient. Finding the best algorithm, combination of predictors, and parameters, we plan to create an ideal country with perfect income equality.
Using different economic and demographics data as our features, we can first explore our dataset from an unsupervised perspective using 2 techniques. We can employ dimensionality reduction to determine which of our features are the most relevant. We expect lots of different economic statistics we analyze in our model to be correlated to one another. As such, techniques like principal component analysis would allow us to reduce our dimensions to components that capture the most variance in our data. This will help reduce complexity and improve the results of our next step, clustering. We can use algorithms such as k-means, mixture models, hierarchical clustering, or dbScan to group together countries with similar features. We might expect countries and organizations like the EU or OPEC to form clusters.
For supervised methods, we want to develop a prediction model that would output our predicted Gini coefficient for a specific country in a specific year, given other parameters like happiness scores or morality ratios. We attempt to find correlations between the weights of these factors and the prediction accuracy. We would also use multiple supervised learning models and elaborate on their performances with the specific tasks, including linear regression, k-nearest neighbors, and neural networks. Due to the limited data points available in the high dimensions of data, we expect the k-nearest neighbors to perform the most poorly. We expect linear regression to perform the best because most of the parameters we'll be using would likely be closely related to Gini coefficient.
We may struggle with acquiring sufficient data as well as successfully identifying the best features. We hope to address number 1 by extrapolating when necessary and taking a time plot of countries' data over a certain period. And for number 2, we plan on delving into methods like sklearn-Python and PCA for dimension reduction. The conclusions of our research could have implications for predictions of income inequality from both expected factors like government style as well as unexpected factors like COVID vaccine distribution.